Hello friends, welcome to VLSI Techno. Now I will continue the Virtuoso tutorial first. So I already talked about the library creation and library path in a cds.lib file, schematic design and symbol creation. So now we'll continue. So this is the test bench of inverter. Now we apply the supply here. Okay, so for giving the input supply we use analog lib. So go on analog lib. So I am going analog lib. This is a analog lib library in which we select VDC for VDD. So just type here VDC. Okay, sorry, this is analog lib. Just type VDC. So VDC come, just click on symbol. Okay, now here give the supply. So DC volt, this is for VDD. So just give 1.8 volt supply, or you can, as you wish, if you want to give to 1.2 volt, 1 volt. So actually we are using a 180 nanometer, and a maximum supply voltage should be 1.8 volt. So we apply 1.8 volt here. Okay, so this is if you want to rotate, just click R, it will rotate. Okay, now we apply to input, giving supply to input file, input, go to analog lib, already given here. We go to V pulse. This is V pulse. In V pulse, both option, you can also apply DC voltage here and pulse also. So I apply DC voltage 1.8 volt currently. Afterward I will change here and make a variable. So making variable, just press any X, Y or anything. If you make X, it will consider a variable X. So firstly I give a 1.8 volt supply, DC voltage 1.8, and define period. So it is your wish. So I am here defining period of 20 nanosecond, and keep here I note doesn't provide any delay or rise time, fall time. So I directly move to pulse width 10 nanosecond. If you want to 50% period, so we apply pulse width 10 nanosecond here. Now apply, okay, hide and click here. Now we require ground. So again go to instance, just press I, instance will have come, browse here and click ground. Okay, so ground will come, automatically ground will come here, just hide it. Okay, so now make the connection. You can remove this pin, if it is your wish. If you doesn't want pin name here, so you can remove it also, but if you want to keep, it is no any problem, doesn't show any error. Okay, it doesn't mean here wiring is crossing this, so it doesn't mean it connected. If any connection will come, then such type of circle will appear. Okay, connection is over. If you want to increase the text, so just press T here. Firstly click in on text, and if you want to increase the width size, then it will be using this one, and decrease the size, just press it up T arrow and down T. for any one. If you want to increase this one, if you want to change the style, just click on it and go to property and front size, change front size. If you click Roman, it will different. And this one. Okay, so now I now move to simulation. For simulation, firstly check and save. Okay, there is no any error and no warning, everything is clean. Okay, go to launch and press ADEL, and now digital ADE, and here we firstly click on analysis, which type of analysis you want to do. Here I am doing transient and DC analysis. For transients we provide a stop time 200 nanosecond, and this is accuracy default. By default we have moderate, liberal or conservative, so you can select anyone for your wish. If you are use conservative, it will provide maximum accuracy. If you click on moderate, it will in between, and liberal means it will liberal, not any high accuracy. So if you click on conservative, it will provide high accuracy. And here I doesn't provide any transient noise or another thing, so I doesn't tick here. And dynamic power, no any dynamic parameter applying here, so apply. And for transient analysis, here I am doing only save DC operating point. Okay, now we provide model library. Actually model library required for HCL. If you are using Cadence GPDK or UMC, there is no need to attach model library. By default it will automatically take model library, but for HCL we have to provide. So for that we have to go. Okay, I am providing model library. Okay, and select model. Actually I am using P18, so I check here typical 180. Okay, model library is provided. Now we move to output and select to be plotted and select on design. Click on in output and input as you wish. If you want to plot this one, you also click here. If you want to plot current, so just click on node. If you click on net, it will provide current voltage, and if you click on any node, it will provide current on that points. I am showing here. If you want to move here, just click here, so it will drag up and down. Okay, now click on netlist, run and play. Okay, in the circuit I provide some. When open, click on here, double click on it, it will go to schematic. In schematic what I do, I provide, actually I make here width as a variable y. By default you take 1. Going back to your test bench, just press Ctrl E, so automatically go here backward, and now run. Actually I am removing this, so just delete here. There is no any variable. If any variable is available, just click on variable and click here copy from cell view or copy to cell view. If you are taking from a cell view, just click on here copy from cell view, to automatically variable will appear. Now this is unwanted will come. Okay, now run it. Okay, waveform input and output will come here. Okay, this is input output. If you are choosing any here only, actually I am here choosing input output and DC also. So if you want to change here, no provide any DC, it will come exact value. You can also run from here. You just click here to netlist and run will perform. You can click here or here, both are same. Yeah, click here or that portion. Okay, so this is transient analysis. If now we move to DC analysis. Another important thing I want to tell you, if you want to know the property of your component, just click on DC operating point and click on, firstly go to your component, okay, and click here. So automatically it will appear DC, and if you change here, you can also click here. This is annotation, so click on DC operating point and it will show here. If you click here, it will show the display result. So if you want to know the in which region this device, and just it show here, this is in region 1. So it depends on a supply in which region this circuit is showing. Actually we are applying here this is property of second NMOS device. So here is the also show the region 0. So by using this in DC operating point, click on any device, it will show their property or result, in which region what is the VGS VDS value and ID value. Okay, or you can select here, go to ideal and go to result and go to print and select DC operating point and click on any device, so it will show the result. Okay, now this is the transient analysis. Now we move to DC analysis. If you move here, it will show proper result. Okay, actually this is due to the not proper designing. Actually we are provide both component as a PMOS NMOS as a one width, take width 1 micrometer, but for proper design we have to keep a PMOS double the NMOS width. So here we move to change the width of 0.5, then it will show proper transient analysis waveform. And also it depends on here we choose conservative. If you choose moderate, it will waveform will be different. So it is the different. If you click and run here, the waveform will be different. Okay, this is hello. Actually I am forget to making the connection of VCS to ground, so that waveform is not showing proper. Now again go to save it and make the connection here to VCS as a ground, and now go to and run this. So proper result will come here. Okay, waveform of this transient analysis, and a component will also show. If you want to know, show the component DC operating point or their property, component property, just click on DC operating point, it will show their property, and click here. Okay, I can run DC operating point, and okay, already here is the showing the value GCS and GM. And now we move to do the DC analysis with different supply. For that, we what to do, just change here and apply X. So it is variable X is apply here. Okay, now save it and go to here, variable, edit, and apply X, and the value here is I apply value 1.8, add it, and okay. So now change here and select design variable X, click on design variable and select variable M here by clicking here. Now define the range. I apply from 0 to 1.8 volt the supply. So according to that, DC will be DC condition will be changed. So now everything is set here. Now run this. Okay, the complete waveform, and log this is transient response and this is DC response. So this is if you want to separate this one waveform, just click here, it will separate it. If you want to add, just click here, it will add. Okay, if you want to bold this one, just double click on it, it will appear this trace property. And if you want to click this one, many option style, if you want to solid, this is solid. If you line make bold, thick, if you want to thick, it will, if change here, you can change here also. If you make here, it will this one. If you want to make this, double click on it, okay, make bold, medium, anyone. If you want to change, just you want to yellow, just click here, apply, so it color will change here. Okay, here is also this is DC response according to when input supply is increases. Firstly it is 0, then output is high, and when it is high, output is low. So this is showing the property of inverting here. Now we go for actually another option is go to tool here and go to calculator, and you can measure many things, just like delay. Actually I am presenting here delay measurement. So for delay, just go to all. Okay, here type delay. Here I am showing only delay measurement, how to measure delay. Insert it, go to waveform here and select the signal one and go to the transient waveform here. So select, click on here, so automatically it will come. Okay, come here, input, VN. Now you go to output. Okay, output is selected. First threshold value, so I am putting threshold value 1.5 for signal 1 and 0.18. approximate 90% of up rising value and 10% of fall value falling. So here I am selected, this is falling and this is rising. According to that waveform, actually first waveform is now going to down and this is up. So this is the showing this show falling edge and this is showing rising edge. So according to that I am selected here rising and falling edge number 1, periodicity is 1 and a stop is at 5. Okay, now click OK and here to show the wave value. So this is showing value and click here to show the wave here expression value. So this is the delay in between rising and falling edge of this signal. Actually it's showing some delay here, so know the delay, just zoom it, it will show delay between when zoom it to maximum, so it is showing delay. And just when zoom it, it will show, it will actually time this is this is downing, this is falling and this is rising. So I measure the delay between in this one, this is input and this is output. So when transition of 1.8 to 0 volt, it will take time, and transition between 0 to 1.8 volt, it will also take time. So it at this point we measure the delay. So this is a method of calculation delay. This one, if you want to add this expression in your setup, so just go to here, output setup, go here and press delay and this is expression. So you have to just copy if you want to go just okay. So this is value, just go to here and click get expression, automatically it will come here. And now okay, now when run this, automatically delay value will be show here. So again run it, actually automatically delay value is showing here in this value is showing this one 59 pico. So this is delay of input rising and falling. Now we move here I am showing the use of calculator. So if you want to use show the output value, just click here and select component. Actually here is the list. So before doing this, okay, I will tell it later in video. You can also use here if you want to know the region of changing the supply in which region your device, and then use this opt. This opt automatically it will show the list. For that we have to go this one and now select here. Now again use calculator and then go to opt and select device. Why not coming? Okay, firstly click on device, list will come here. So it is a list, different list. If you want to show the region or anything, if you want to show the region, just click on region. Okay, this is expression. So if I am adding here region, so I am using here region, or for region this using this expression. If you want to use a different, just like here VTH threshold voltage, just click on here. So this is a threshold expression. So if you want to add also this threshold expression, just go to output and setup and add this is for threshold. Using this expression, so this is automatically use threshold value. So if you want to complete this one, just click here, automatically it will show complete result. Okay, we can open this. Okay, here is the complete showing. Region of 1, this is the threshold value of device, PMOS device, and there is delay in input and output signal, and this is the waveform of transient and DC response. Now we move to parametric analysis. So firstly go to this backward. Okay, now close this. Okay, this is the calculator use. There is in calculator many option, like functional option or mathematical function will be completed, functional and a special RF simulation, many. So now we move to another tools, parameter analysis. For parameter analysis we make a variable or in device so that it show proper difference between changing the value and their output. So what I do, firstly click on here and change the parameter. So here I am make width as a Y. So I am varying the width. So save it. Okay, and go back by Control E. So automatically it will come in test bench. So now I am adding from variable. Actually I am define variable, so just copy here. So variable will appear. So I make here by default 1, and also change in. Now click run. So waveform will be same, no any change. Actually I by default I make 1, so that what I do, I have do only transient, sorry, only DC analysis here. Okay, again okay, only one waveform is showing. Now I show you the use of parameter analysis. So just go to parameter analysis and here click here add variables, just click on it, it will show here. So just select Y, it automatically show the value and vary from 0.5 to 1.8. so I am just varying the width of PMOS and showing their effect in output. So just clear. After this we how many step, how many waveform you want to show. So I'm just click 5. If this is your wish, if you want to 10, then it will show 10. So here if you want to add more, just click on add one arrow. If you want to show the variable of temperature, automatic temperature is there. If you want to show, or it will also show. So by default temperature 27 degree to 30 degree. If you want to say one step, so actually presently I am here only one, showing one, and then after I will show different. Okay, this is region width. Okay, this is the DC analysis, this is region information. Okay, this what is, I remove this one. Okay, Now I am showing only input output, so just again run this, so it will show only one value. Otherwise it will automatically generate a waveform of regions. Actually there is no need of region showing here, so okay. Waveform not showing properly, so I make it clear. Okay, this is showing according to their width, output will change. So different width, it will different output. So input is same, but output will change according to width of change in width of PMOS. Okay, this is the use of parameter analysis. If you want to add a temperature again, it will also show different, and 50 degree Celsius. I can make 2, so automatically it will take generate 10 with it crash, so wait a minute. Okay, now it's running, so complete waveform automatic 10 waveform will coming here. So if you click here, so it will showing 10 according to temperature and width of PMOS and NOS. Actually I defined 2 step for temperature, so it will multiply 2 with this one, so it will show temperature, and this is Y, so automatically in here we show Y, and this is temperature. According to temperature and width, it will show the output variation. So this is use of parameter to analysis. So actually it will total generated step is 10, multiplication of first 5 and 2. Okay, so this is the first tutorial completion. So in this tutorial I discuss CDS lib and library creation, semantic design, symbol creation, and their test bench, and then after we do simulation. In simulation we do perform transient analysis, DC analysis. I change the supply and show the DC response, and I also show the property of device by using a DC node here, DC operating point, and select device, so it will show the property of device. And now we perform the delay and also show the different region. By changing the supply and width we show the different region, and that is solved, and delay in input output signal. So this is completion of first tutorial. So if you like my video, just click on like button and subscribe my channel. So thank you for watching my video.